These explanations are to help you with exercise 2B on factoring expressions. Factoring expressions, as it says above in green, means to write a number or an expression as a product of its factors. So back in earlier grades, you might have done this by doing it with numbers. Let's take number 12. If we want to factor number 12, then we look for things that multiply to give us 12. Say 3 times 4. And maybe we even want to do it as prime factors, in which case we would take that 4 and write it as 2 times 2 and make it 2 times 2 times 3. So 2 times 2 is 4, times 3 is 12. This is how we write 12 as a product of its factors. 2 and 3 are factors of 12. That means when you multiply them together, they equal 12. We're going to do the same kind of thing, but with algebraic expressions. So the first pattern or first method, the first thing we can look for in helping us figure out how to find the factors of an expression is to look for common factors. That's what you see here, common factors. So we have two terms, 6x squared plus 4x, and we're looking for something that they have in common, some factor they have in common. Sometimes it's helpful to write this out as its prime factors because then it becomes more obvious. This is a step you can skip once you get a little more used to it. But to start off with, let's write 6 as 2 times 3, and the x squared we'll write as x times x. Trying to make a big difference between my multiplication signs and my x's. I hope that's clear. Okay, the other term, we have 4, which is 2 times 2, and just a single x. Okay, which of these factors are in common? Let's underline them in green. Here I have a 2, and there I have a 2. So 2 is one common factor that I'm going to take out. And then I also have an x and an x in common. So I'm going to take out the 2 and the x on the outside of the brackets and then write what I have left over on the inside. So if I took out this 2 and this x, what I mean by taking out is actually dividing. So if I divide 6x squared divided by 2 and divided by x, I'm left with 3 and an x because there were 2 x's to begin with. If I take one out or divide by one of them, I still have the other one. Okay, so if we take a 2x out of 4x, over here, the 2 is gone, the x is gone. If we divide 4x divided by 2x, we'll just have this 2 left over. So then we get plus 2. And now we have 6x squared plus 4x, this expression here, written as a product of these two factors. Remember that product is the answer when you multiply. So product always has to do with multiplication. Yeah? So that's why these two things are multiplied together, and that's why they're products. So that would be your final answer, 2x times 3x plus 2. Okay, let's try one that looks a little bit more complicated. Here we have something that's kind of already factored. We have negative 4 times a plus 1 and a plus 2 times a plus 1. These are all factors already. This is a plus 2 is a factor of this expression, and a plus 1 is also a factor of this expression. And here negative 4 and a plus 1 are factors of this first expression. So this is already factored for you, and now we look and see what are the common factors. Common factors don't have to just be a single letter or a single algebra variable. They can also be things like this a plus 1 and a plus 1 here. That's a common factor. It's part of both terms. So we're going to take out a plus 1 and divide both terms by a plus 1. This one I have to put in brackets. I could have put this in brackets as well, like this. But this one I have to put in brackets because otherwise this isn't treated like a group. If I divide this expression by a plus 1, then the a plus 1's cancel and I just have a negative 4 left over. And if I divide this expression by a plus 1, I'm left with a plus 2. Okay, I've put it in brackets for now, but maybe we don't need those. Let's see what's happening. Negative 4 plus a plus 2, this is all adding, so I can actually put those together So I get negative 4 plus a plus 2 without the brackets. It's just a 1 out in front, so 1 times a and 1 times 2 is all going to be the same thing. And then negative 4 plus 2 can be simplified to give me my final answer. So a plus 1 is one of the factors. Negative 4 plus 2 is minus 2, so I'll write a minus 2 is the other factor. And that's now completely factored with everything boiling down to a product of two factors. Okay, that's the common factors method. Here we're going to learn about two other patterns that we practiced expanding before. Now we have to go backwards the other way. So whereas before I expanded this to get a difference of squares pattern, I now have to recognize the pattern as giving these two factors. Likewise here, the perfect squares pattern, when I see this, I should know that that makes this expression. Let's start over here. So A and B are just placeholders. When you use this pattern, you don't necessarily have to have an A and B in the question. But we want to find something squared, and then on the other side, something else squared with a minus sign in between. If we find that, then we have a difference of squares pattern. So let's look at these two expressions. Can I write 4 as something squared? Indeed, 4 is 2 squared. So put the thing that is being squared in brackets just to make it really easy to see. And on this side, is there something that's squared that can go inside the brackets? From the 9, we could put a 3. And from y squared, we can put a y. And now I can kind of see, let's take a different color here, okay, and kind of see that if the 2 is the a, if that's a, 2 is equal to a, and if 3y is equal to b, then I have a difference of squares pattern. 2 is squared, and 3y is squared, and they're subtracted. So that's a difference of squares. This is a square, that's a square, and difference is the answer when you subtract. So when I write what the factors are, I can use this pattern up here. I know whatever my a is, that was 2, is going to be added to whatever the b was, that was 3y. And then I multiply that by a again, which is 2, and subtract 3y. Kept the different colors there. Let's go back to blue. If I want to check if I'm right, all I have to do is expand this to see if I get 4 minus 9y squared back again. So 2 times 2 is 4. 2 times negative 3y is minus 6y. 3y times 2 is plus 6y. And 3y times negative 3y is negative 9y squared. Doesn't look quite the same until I notice that minus 6y plus 6y cancels, so these two terms equal 0, and I just get 4 plus 0, which I don't have to write, and minus 9y squared. And that is indeed the same as this. So this is my factored answer, using the difference of squares pattern. Let's try it over here. If you want, you can pause the video at this time, try it yourself, and then look back at the answer. Okay, let's see if we can find something squared. Oh, hold on a minute. A is not squared. That's not going to work. Why don't we look for common factors first? That's always a good first step, is to look for common factors. I see that between these two terms, they both have an a in common, so I'm going to take the a out first. And I get 9 minus 16. If one a has been divided, then I still have an a squared left. Okay, so this a is one of the factors already. It's one of the, just like when we did 12, we first made 4 times 3, and then we made 4 into 2 further factors. So here we've already split it up into 2 factors. Now we have to go and make this one into 2 further factors. So 9 is 3 squared. We can put the 3 here. And can I see another possibility of squaring something here? 16 squared is 4, so I can fit a 4 in there. Forgot the squared. And a square root is a. So there's 4a squared. That makes 4a times 4a would be 16a squared, and the minus sign in between. So there's my a, and 4a is my b. And don't forget, we still have this factor as well, so that one's got to come in as well. So the final answer is a on the outside for that first factor we found. And then 3 plus 4a, because the pattern says a plus b, so first my a plus my b. And then 3 minus 4a to complete the pattern. A minus b. And that's then the final answer. That's now been factored into 3 different factors. Okay, we're ready for the last one. Perfect squares. This was our perfect square pattern. There's something missing here. If this middle term is subtracted instead of added, then the pattern is exactly the same, but this bracket will be subtracted instead of added. So it can be plus, then it's plus over here. If it's minus on the second term, then it's minus over here. Okay, how do we get this into this pattern? In the front, we need a term squared. So we're going to try to make we're going to square root this and see if we can write something in there. And then we need to have b over here squared. And we need to see if the middle is 2 times this, because this a is whatever you put in this bracket, and this b is whatever you put in this bracket, and we have to multiply it by 2. So we'll see that at the end, if it works out. And if it works out, then we can use this pattern to factor it. So square root of 4 is 2. Square root of x squared is x. And then we go to the last term. Square root of 1 is 1. So far it looks good. This squared makes 4x squared. This squared makes 1. Now here comes the check. Is the middle term 2 times a times b? So the middle would be 2 times, I'll just do a dot to save space. Whoops, that always comes up when I do dots. 2 times 2x, that's my a, times 1. Okay, it's 2 times 2x times 1. Is that 4x? 2 times 2 is 4. 4x times 1 is 4x. So yes, indeed, that works. That means that this factored is going to be a, which is 2x in this case. Right? Whatever was here squared is going to go here. So that's 2x plus 1 squared. And that's the factors of this. Why is it squared? Remember when we did 12 at the very beginning, we had 2 times 2 times 3. Maybe you remember back in, I don't know, grade 7 or so, that you could also write that 2 squared times 3. When we repeat factors, we can do it as a shortcut using powers to show multiplication. So here, this 2x plus 1 is really, if I would write out the factors separate, is 2x plus 1 times 2x plus 1. But that's just the same factor doubled, so I can write it like this as a shorthand. Okay, one more example. If you want to try it first, look for common factors before you start, just like we did over here with part B. We're going to go ahead then and see if we have any common factors. There's only x's in the first 2 terms, so x is not a common factor. What about in the coefficients, in the numbers? There's 2 and 4. That's got a factor of 2 and 4, and this only has a factor of 2. So let's start by taking out a 2. Then I'm left with 4x squared minus 12x plus 9. And now I can go on to see if this can be factored further using the perfect squared pattern. The 2 again just follows through and has to be remembered at the very end. I wanted to put an arrow on that. Okay, so let's see if this beginning, if we square root that, can we make something squared? 4x squared we've had before. We know that's 2x. The last term, square rooted, is 3. And now we check the middle. One thing we notice right away is that there's a minus sign here, so this middle term is going to have to be negative, and then we know we use the negative pattern rather than the positive one. Okay, the middle has to be, if it works out, has to be 2 from this 2 times 2x from the A part times 3 from the B part. We check, 2 times 2 is 4, times 3 is 12, so minus 12x, indeed that works. That means we can go straight to the final line. We need our 2 that we factored out from the beginning, and then I have 2x plus, ooh, not plus, right? What we have to remember here, it was minus. So I need the minus sign here as well. So 2x minus 3 squared. And that's factored. That's done. Okay, time to try it yourself on exercise 2B.